Okay, so we're going to do a little bit on rotation of two-dimensional solids. So the revolving door is a pretty classic example. Look at the picture. Do you see the two-dimensional solid that actually, two-dimensional figure that actually creates the 3D solid? Okay, take a moment to review the difference between your two-dimensional figures and your 3D figures or solids. Okay, so let's talk about how we take a two-dimensional figure and actually do a rotation to get a 3D solid. So when we say rotation, right, remember that you have to turn about a center, and you also have to have what we call an axis of rotation, rotational axis. Take a look. Okay, so here is the diagram, right, of a triangle. It's a right triangle. And we're using the pencil, right, to show the rotational axis. So if we rotate that right triangle around that pencil, which is the rotational axis, what figure, what 3D solid do you think we're going to get? What did you guess? If you guessed a cone, you are correct. Cone is going to be the solid that comes about from when we are rotating the triangle about one of its legs. So notice we were using the leg to do the rotation, right? It would look different if we were using the hypotenuse. Okay, what 3D shape is produced if we rotate a semicircle? Think about that for a moment. Now, if you were thinking, oh, but you have to tell me, right, where's that rotational axis? Because it does matter where you put the rotational axis. So take a look at the picture, right? And if the rotational axis is right along the diameter of the semicircle and you rotate about that, then indeed you're getting a sphere. All right, think about that. That would be different if I put the axis of rotation right through, right, going vertically as opposed to horizontally, putting it through the center, right, vertically. That would create an entirely different shape. Okay, now here's two for you to try. You're given the 2D figure. You're given the pencil, again, is acting as our rotational axis. So take a look and see if you can imagine the 3D shapes you would get. Okay, let's see how you did. Okay, so if we take our square in number 1, and again, this is our axis, right, where the pencil was, and we rotate around, did you say that we would get a right cylinder? Okay, and if we have a circle and we go right through the center, right, and it wouldn't matter if this was vertical or horizontal in that case, we would get the same 3D solid. Did you say a sphere? Okay, hopefully you're getting the idea here. Okay, let's talk about, well, what if I'm having a little trouble with this? Is there really a method that I could follow? Oh, ask and ye shall receive. Yes, there is. So remember, you're going to be given the 2D shape, and you're going to be given the axis of where we're going to rotate. All right. So here is a 3-step method. Draw your shape and shade the region that you want to be rotated. Just like this. So let's take that right triangle, right? Here's a right triangle and we shade it in. Okay, next, draw a reflection, which is the mirror image, of the region the region about the axis or line of rotation. Now, in this case, I have to tell you which is going to be our axis of rotation, the y-axis or the x-axis, or I could put some other line and call it the axis of rotation, right? But in this exercise, I'm going to tell you we're going to use the y-axis, right, as our rotational axis. So now, right, on your scrap piece of paper, would you draw the reflection of this right triangle about the y-axis? We've done reflection, so reflect it right over. Did you get that image? Hopefully, yes. Okay, now here's the really cool thing. This is actually how you get the visualization of the 3D solid. You connect the vertices of the original image and its reflection using curved lines. So think about it. This point right here, right? Where is its new image? Well, it's right over here. And if we connect this with a curved line, right? This one stays the same, so we're not going to connect it at all. This is where we're going to connect with that curved line. Look at what we get. Voila, that cone. So this is kind of, again, a 3-step method that you can always use, and it works. Okay, so let's take a look at, right, a word problem that involves a rotation. So sometimes in the rotation problems, you're just really asked to say, okay, here's the 2D figure, here's the axis of rotation. What 3D solid is created, right? But sometimes they're actually embedded in word problems. So take a look at this one. We have a square with the area of 100 square centimeters, and we're rotating it, right? They're telling you that you're getting a cylinder, but we want to know the volume of that cylinder. Well, you know the volume of a cylinder, right, is formula driven. It's on your reference sheet. You can look it up, okay? And if you do, it's pi r squared h. So in order to find the volume of the cylinder, we need to know the radius of the cylinder, and we need to know the height of the cylinder. So again, we need to know this radius, and we're going to need to know this height, right? And we're going to get that from looking at this rotation. So if this area of the square is 100 square centimeters, think for a moment and think how you would get what the sides of those square is. You said 10, right? Because 10 times 10 is 100, or you can do it mathematically. Okay, so now let's translate that to, okay, so what is this 10 and what is that 10? Right? Well, this 10 becomes the height, and this 10 becomes the radius. So now I have what I need to get the volume by simply substituting in both of my 10s. And that would be 1,000 pi, or about 3,142. Okay, here's another word problem for you. This time we're given a cone, and it has a radius of 6 and a height of 12. Okay, it wants us now to find the area of the triangle that's formed from the perpendicular cross section. So what we're showing here is I come down and I slice this cone, right, perpendicular through that apex, and you can really see, right, what I get. I get this triangle, right, that's formed from the perpendicular cross section. So now really all I have to do is, okay, translate where the 12 goes and where the 6 goes. And then how do I find the area of a triangle? Well, if you don't remember, and it's a shame if you don't remember the area formula of a triangle, but it is on the reference sheet. Area is 1/2 base times height. So again, what is the base? What is the height? Right? The base is 6. The height is 12. Half of 72 is 36 square feet. So that would be the area of that triangle. So you can see how they're used in word problems. And going back to other things you need to know, right? You can't forget area and perimeter. You can't forget your two-dimensional measurements when we're talking about three-dimensional measurements. Why shouldn't you let advanced math intimidate you? Think about that a moment. Well, because it's really as easy as pie. Ah! I know you missed my corny jokes, so I threw that one in for you. And to end on this note, review your edge, vertex, and face with this cartoon. I tell you, kids. All right, guys, I hope that was helpful. This is Action Jackson, signing out.